Today's lesson, it will be about two-dimensional drawing in WPF. And first we will open our new project. In this project, we will draw some shapes in a canvas, and we will not only draw them, also we will assign click events to them. So when you click on them or drag them around, they will move. I prefer adding shapes from code because I can add them for one time from XML, and you can just, like inside canvas, you can just write an object like ellipse, rectangle, ellipse, and you can assign the thickness of the brush, the color, and everything from here. But this is not a convenient way, because as you know, in graphics, adding it programmatically, removing it programmatically, and being able to modify it from the program, from code, is much more flexible. And at least in the applications that I made, I was required to do this. As you see, I just write an ellipse object in the canvas, and I choose the color, height, the width, the stroke thickness, and you can see it already created to the left top corner. And you can, the canvas dot left parameter is how far is the left side of the object from the origin of the canvas. So if I write 100, it means there will be a space of 100 between the origin of the canvas and the left side of the shape. As I said, this is easy, but I prefer creating this from code because I can give it a name. But let's say for each object you have to add a new circle, because the interface is programmed at the beginning once, and after that you won't be able to add more. So we will do this from the program. To add new shapes to the canvas, I will use a context menu. So what I will do is, when you right click on the canvas, it will show me a list of shapes, and I will just click one of them and it will add a new shape into the canvas. First, let's give it a name. I will name the canvas drawing canvas. The preview right up button, and to go navigate, I will just go to the, don't need this. So this is what will happen when I right click on the canvas. I want a context menu to show up with a list of objects. I didn't want to add these on the left side because every time you add a button into the interface, it looks more crowded and more complicated. So the business that's done with the canvas, I want to use it on the right click context menu. So first we need to declare a context menu. When I right click on the canvas and I leave the button, a new context menu will be created, and I want this context menu to be created where the mouse is, and I edit the placement function of my new context menu, and this is the mouse location. System Windows controls primitives placement mode dot mouse point. And then inside this context menu, I want there to be buttons that represent shapes. So each button inside a context menu is called menu item, and I'll just delete this old one. So I will declare a menu item. Let's rectangle. So to create a rectangle, there will be a button, context menu button, which is called a menu item inside the context menu. The name of it is rectangle button, and I can declare it like this, and on the row below I can write, on the line below I can write rectangle button dot header. But what I prefer is a one-line code, which is like this: header equals so this is my first button. My second button will be circle button. And a line button. Okay, so I have 3 buttons. I declared them and I gave headers to them. A header is basically what it will write on the button. And to my context menu I will add each of them. And finally, to show my context button, there is a function here. I just make the is open property true, and then my context menu will be visible. So let's give it a try and see what happens. And you see the buttons are here, and when I right click on the canvas, a menu with 3 buttons will appear. See, rectangle, circle, and line. If I click rectangle, I want to add a rectangle shape into my canvas. To do this, as you know, before we declared each button of the context menu before, in the rectangle button I will put an event. So I will add an event for the rectangle button object. I can use click here or mouse up. but both clicks should be okay, either right or left. So I'll use the standard mouse down event, and I'll let it automatically choose a name for me with tab. And the same thing is for the circle button. With the tab key, it automatically gives a name for the event. And you see here it automatically also creates the block for it. So I advise to use it. So now we have a context menu, and there's 3 items in it, and the header that's showing what it writes on the buttons are written here. And there's each button click events are designed from here, the mouse down event. And after I declare the events and what happens when the button is clicked and what it writes on the buttons here, I add them to my context menu, and then I make my context menu visible here. And when I click on these buttons, when I click on the rectangle button, I just want to put these in order. I prefer my code to be long and clear instead of short and confusing. So it's very important to keep your code neat, because in big projects, after many lines, everything just starts getting messed up and you have trouble finding whatever it is. So when I press the rectangle button, what I want to do is I want to add a rectangle in the middle of the canvas. And then I'll change the position by dragging it and dropping it with the mouse. So what I will do is I will create an ellipse object. As I said before, I like to declare objects in a single line because it prevents the code from stretching down. The height is 150, width equals 150. The color part is a little tricky. Yeah, you need to use brushes. And the stroke type, the stroke thickness, I want it 5. and fill. So a circle will be created, which is 150 in height, 150 in width, and the stroke, the lines around the circle, is black, and the thickness of the stroke is 5, and the inside filling of the circle will be red. But I added it to the rectangle, so I made a mistake. This will be inside circle. In the rectangle, it's actually similar. The commands of a circle and rectangle are very similar. As you see, it's the same. There's a height, the width. If the height and width are equal, it will be a perfect circle. But if you change the height and width, it will be an ellipse. So that's why it's called an ellipse, because you can modify the height and width. But I will stick with a simple circle. And we have a line. In the line, there's start point and the end point. So we use x1 for the start points x. So first I'll make them 0 and make the declarations. So the length of the line is determined by the distance from x1 to x2. So I declared my shapes, but as I said before, when I add them to my canvas, I want them to be in the center. At the moment, there is nothing that tells my application to create them in the center. So in WPF, when you want to place something in a certain position inside a canvas, there's a set left command. So you basically declare where the left top corner will be inside the canvas. I'll show you with a sample so it's more clear. And to find the center of this canvas, the name of it is drawing canvas. What I will do is, after I declare my rectangle, I will use canvas.setLeft, and I will choose the object and then define the left corner, the X position of the left part of the rectangle. So I want it to be I want the shape to be in the middle of the canvas. So I need to make the center of the rectangle to be fixed into the middle. To do this, I need to calculate the middle point of the canvas. So it will be middle point of the canvas minus half of the shape's width. To do this, it's actually simple code. I will write drawing canvas dot actual width divided by 2. So this makes the left top corner of the rectangle into the center, but I want the center of the rectangle to be in the center of the drawing canvas. So I need to shift it half size of the rectangle to the left. Notice that I'm using white in the rectangle because the rectangle isn't displayed yet. It's not shown yet. It's only created inside the memory of the computer, and the actual height property is after the rendering is done. It gives me the actual width because in WPF, maybe you have noticed before, there's no fixed height and width of the main form, the main window. So you see it's primary screen height. So this can be anything because it depends on the screen of where the application is running. After the main screen is rendered, the columns will be rendered, and as you know, our canvas is set to fill the column, and the size of the column, it depends on the size of the main window. So after the main window is rendered, the two columns will be rendered, and the buttons will be rendered, and the canvas will be rendered. After the rendering is finished, the actual width parameter will give me proper information. But when you create a new shape, because this shape it's not rendered yet, so it doesn't have an actual width parameter. After the rendering is finished, it automatically calculates it. For example, maybe if the height and width of this rectangle wasn't fixed, let's say I didn't want it to be 150, but I wanted it to be 1/10 of the width of the drawing canvas, I could have made it like this. So it will be connected to the width of the canvas, and in some situations the actual width will give you a NaN error, which means not available, and you will have problems with this. So you need to know the difference of actual width and width, because the width is after you declare the height and width you can reach it. But if you have some chain reactions, which shapes will be created after another shape is created. Let's say you want to create a rectangle, and in the middle of this rectangle you want to put a circle inside. Before the main rectangle is created, you cannot make any calculations with the size of the center circle because the main rectangle isn't created yet. Of course, there's a method to get this information sooner than the rendering process, but that's another part for another lesson. At the moment, we're keeping things simple. I find the middle point of the drawing canvas, and I calculate the half of the width of the rectangle, and after I close my parentheses, the rectangle center will be in the center of the canvas. And I did this for the x-axis. The set left function moves the shape left and right. I have to do the same thing for the vertical axis. So I will use set top. This time I will use actual height divided by 2 and the rectangle's height divided by 2. Actually, this is a square. The height and width is the same, so I'll make it a little more longer so it will be a rectangle. And after I set my top, I will add the rectangle to the canvas. To do this, I choose the canvas .children.add So I create the rectangle. I define the left and top position of the rectangle inside the canvas, and then I added the shape, the rectangle, inside the canvas. So the canvas is like a container and the children are the shapes inside this container. And when you use this canvas.setLeft function, it automatically places it in relativity to the origin of the container this shape goes into. So canvas is the canvas that this shape is added to. So when I use a rectangle and give it a position, it automatically locates the origin of where the rectangle is contained, and it gives a relative position according to the left top corner of the canvas. So let's test it. Shit, something's wrong. Let's see what's wrong. So I go to the rectangle button mouse down event. I put a breakpoint and try again. The event is not being triggered because the mouse down event is not working. Instead of mouse down, we need to use click. The mouse down event and the click event are different type of events, so I'll create them again. So the mouse down event was a mistake. I used the click event instead of that. And let's try again. Okay, now it works. You see, just as I wanted, it has a black stroke with a red filling, and the center point of the rectangle is the center point of the canvas. And we're gonna do the same thing with circle and line. The same method will not work with the line because the line already has a specified coordinate location which is defined by x1, y1, x2, y2. So what we're gonna do is we will place the line in the center of the page by using these coordinates. So we already know the center. To make this easier, we will write a little more complicated code. because in here we will not be able to use a single line code, because in the single line code everything is declared at the same time, because here we are using x1 as reference. The x1 is not created yet, so it doesn't allow me to use x1. So I have to break this. So we change the code. Instead of using get left and set top, we directly used the information, the data, to modify the beginning point and the end point of the line. What we did is we calculated the center point of the canvas, and from this point we went left half the width of the line, so the center of the line was at the center of the canvas. To see better, I will make the circle a different color. Instead of red, it will be blue. So let's try everything again if it works. So we have a rectangle, circle, and line. You see, everything is perfect. Now what I want to do is I want to click on it and drag it into another location. Now this is where it starts getting tricky. So now we created the shapes inside the canvas. Now I want to move them with my mouse. To do this, first I need to be able to locate the shape. So when I click on it, I need to find which shape I clicked on, and then I have to change the location of this. To do this, first I know that the shapes are inside the container, the drawing canvas container, but let's say there's 2 or 3 circles inside. How am I gonna distinguish them? And I need one more thing. I need to assign an event. When this object is clicked on, what will happen? So a rectangle dot preview mouse, preview left button down. You see, this is what I was meaning when I meant to add the shapes from code. If I added these from here, I couldn't do what I'm doing now, because I can only add one of them, and I want it to be fully dynamic. I want the user to add many circles as he wants, many rectangles as he wants. Okay, so when the mouse is clicked on this shape, I need to get this shape, and when I move the mouse, the location must change. So when the mouse is down on this shape, what I will do is first I will convert this into a rectangle. I need to save the initial position of this one. To do this, I will create two independent variables. Drag start location X. I can add two doubles. One is the X location, one is the Y. Or I can simply add a point as well. The X of this point is canvas dot get left. We assign the location with set left, and when we read the location we use get left. Canvas dot get left rectangle R, and the Y position is get top. So now I have the initial location. When I click on the object, I save the first location, and when I drag the mouse, the new location will be the delta of the dragged distance to this point. I also need to have a mouse up event. So when I click the mouse, it saves the initial location, and when I release it, it will move the object to the location I released the mouse. So I copied the code same as the rectangle to the other objects. So when I click on an object, I will get the initial location. I will get the clicked object. Actually, instead of using the object's beginning point, I will get the mouse click location. This way the animation of the moving will be more smooth, because if I use the location of the object after I release the mouse, the object will have a jumping kind of look because I am not clicking on the top left corner of the object. So I will use the mouse location. Okay, so I got the mouse position relative to the screen as a start point, and after I release the mouse button, I will find the delta between the initial clicked position and the release position, and I will add it to the object's location. I didn't use the object's location within the canvas because when I click on the object, there may be a slight difference in position because maybe I'll click on the bottom right corner of the object and the place I click is not the origin of it because the top left corner is the origin. So when I release the mouse, there will be a jumping effect. The effect will look like when I release the object, it will jump a little left or a little right because the first place I click isn't the origin of the object. Maybe I will click it in the center or the bottom right corner. This is why I will use the exact mouse position as the beginning. Now I will write a mouse up event. I'll write the same event for the circle. And finally, mouse up event for the line. Okay. So when I click on an object with the mouse, and when the mouse is down, the button is held, I get the initial mouse position of where I clicked, and when I release the mouse, the object, it will be fixed onto the new location where I released the mouse. So before I made a drag start point, now I will make a new drag end point so I can know how much I moved the object. And after I release the mouse button, so when I first click the object, I have the drag start point. I saved it. And after I release it, I have the drag end point. So I can find the distance of how much the object moved from these two locations. In the line, I modify the X and Y positions. Here I need to modify the location using set left. So I need to get the old location, add the delta to it, and use a set left command and set top command. I will do the same thing with y-axis. And now I will use set left, but I will add delta to it. Previous location plus delta x. So what I did is, when the object is clicked with the left mouse button, when you hold the mouse down, first it gets the object that's clicked and converts it to an ellipse, and then I save the mouse clicking location. Inside the mouse down event, you can get the mouse location with get position command, and this is basically main window. Like, it will get the location of the mouse cursor from the top left corner of the main window. So when I click on an object, it will give me the location of this object in the main screen, and when I drag the object and release it, I will subtract the second coordinate from the first one and add the difference to the old location. So from the two mouse events, I calculate the difference, the delta, and then after I release the mouse, I add this difference to the location of the object. So you see here, I click, I got the start position before dragging the object, and also I save the object. I will use this in the future, you will see. And after I release the mouse down, release the mouse left button, I calculate the delta from, I get the new current position of the mouse, which is the new location. I subtract it from the old one and get the delta, and then I add it to the old location of the object. And the old location is, you get it with canvas.getLeft and getTop. Then I add this delta to the previous location and set the left point and set the top point. The circle is okay, only rectangle remains. So let's try if it's gonna work. Rectangle, I clicked on it, I'm moving it, and it's not working. Something's wrong. Let's see if the events are being triggered. Okay. So I got the start point, I got the clicked object. So the first event, which is rectangle preview left button down, it's working, but there's something wrong with the second one. Okay, the problem is the event is not working because this preview mouse left button up requires me to lift the mouse button inside the object. So this is not good for me. This doesn't suit my needs because I need to move the object outside the object limits. I can move it anywhere I want in the canvas, so this is not the correct use of this. So we need to, instead of this, as you remember before, we saved the object here because the mouse will go outside of the object, so when we release it we will lose the object because it will no longer be rectangle preview mouse left button down. The mouse will not be on the rectangle. So here, this clicked object function will be very beneficial for us. So what we will do is, the left mouse button up, we will change it. Instead of the object, the left mouse button up will be triggered in the main canvas. So here in this drawing canvas, preview right, we have a right button up. I will add left button up here. So I will do the same thing, but instead of 3 separate events of mouse button up, there will be one event, and this will be triggered in the main canvas, the drawing canvas. However, when I release the mouse, I need to know the clicked object, because my mouse will exit the object. This is why I save the clicked object into another variable, so I can reach it later. So what I will do is, I will use the same code. I don't need these anymore. Mouse button up events are not useful for me anymore. So I have a clicked object, and this is a simple variable which is an object type. As you know, object types are the highest level of objects in variables, so I can assign anything to an object. So I save it as an object. If it's a line, it's saved as an object. If it's a rectangle, still it's saved as an object. It will be a temporary buffer for me until the mouse is released. In the mouse release event, I will have a simple if block. If clicked object is line, else if clicked object is rectangle, ellipse, and else is nothing, because else it will be null or it will be some kind of gibberish object. So I don't care what else is, I'll just close the block. So if the object is a line, this code will execute. If the object is a rectangle, So if the object is a rectangle, I need to convert clicked object back to a rectangle object. So rectangle C will be clicked object as rectangle. And to simplify the code, I don't need to repeat this part because it's same in all of them. So I'll just write this on top. I'll turn this into an R so you don't get confused in the code. Okay, and finally normally you can reduce the lines. You can directly use canvas get left here and get top here. This way it will be cleaner. And also see, so now it should be okay. And just to be sure, we should write something like this. Instead, we don't choose any object and click on an empty space in the canvas. If the clicked object is empty, it should return. And after the left button is up, we should make sure that the clicked object is emptied, because in the next click it's safer to make it empty, because this way it won't affect anything. So if we click one object, change the position, and after the first object is clicked, if we click an empty space, the object we moved before may move because that was the last one we selected. So let's try our code, see what happens. We added the rectangle, and now I clicked on it, I'm dragging it, and when I drop it, it goes to the new position. As you remember in the code, when I click on it, it saves the location of the mouse and it saves the clicked object, and when I move it and at the mouse up event I release it, it calculates the distance between the first click and the second click, and then it modifies the location of the object by adding the difference between the two cursor locations to the object location. But I'm not satisfied with this. Let's try it with the circle. The circle is working as well. But what I want to do is, when I drag the object, I want to see it. I want it to follow my cursor. Actually, it will be the same code, but when we put the same code in the mouse move event, it will just, every time the mouse moves a little bit, it will launch the same code. So let's see. Okay, delta. And because the object will be moving at the same time with the mouse, I won't be needing to use the mouse up event, because this event will happen in every little mouse movement fragments. So I can remove the mouse up. So let's see what happens. Nope. Let's put the breakpoint here, because even if there's no clicked object, the breakpoint is working. So rectangle. So we have the endpoint, we have the delta, start point. Yes. It's a rectangle. Yes, so this is our problem. After it's moved once, we made clicked object null, so simply forgets the clicked object. So this is not good for us. Okay, let's try again. Oh, it's working, but it's going crazy. Why? Up, down. Ooh, some crazy shit's going down here. It's because when we move the mouse, there's some kind of loop here. There's a paradox actually. When we move the mouse, the rectangle moves already, and this get left location changes. Before, this code was working because the rectangle was at the same place until we left the mouse button up. But now, because with each movement the rectangle is moving, the rectangle is moving too much, because the delta is being added to the rectangle location, and then the rectangle location updates and the delta is added another time. So the movement is like, the more you move it, the more extreme it goes, because delta is added many times and it forms some kind of infinity loop. So we need to, before, when we need to use drag start point at the beginning, and we need to add delta to the drag start point, because the drag start point is saved once, and even if you move the object how much you want, it will still be relevant to the first position you clicked on it. And this is something that can make you go crazy, because I remember when the first time I was making applications with 2D graphics, this problem was like, I spent so much time thinking what the hell is going on. Okay. Okay, now it's moving smooth, but there's a problem. It's not letting go. Why? Because we click it and clicked object is chosen, it's assigned, but when we release the mouse, nothing happens, because the event is in mouse move and the mouse is moving. So there's some kind of a logical error in the code, because we didn't tell when to release the object. So we will put a mouse up event, left mouse up event actually, to the drawing canvas. Mouse left button up. So when we release the mouse, clicked object equals null. This should do the trick. Okay, it releases it, nice, but when I click on it and move it, there's something wrong about it. It seems like there's some kind of offset as big as the width of the rectangle. Yes, the problem is, as I said before, I fell into the same mistake as I warned you guys. The delta should be added to the initial location of the object. And in here, I got the drag start point. This is actually where I click on the screen. So it doesn't give me the correct position. What I will do is I will create a new point, which is object start location. and this location will be the first location of the object. In the line, the start position is x1. So when I add y to x1, it will automatically calculate click line length. Yes. And please note, this is a simple line, a horizontal line. If the line was vertical, then the code would change. This is just to demonstrate how to move it. You have to modify the beginning point and ending point. So in other cases, you have to write a code. If you have a line, if the line x and y is different, you have to modify it differently. For example, our line is horizontal, so we just add to the x, but if it was vertical from down to up, then we would have needed to change the y coordinates as well. Now what we did is, when we click on the object, for example a rectangle, first we got the object as sender. As you know, sender is the object that triggers the event. In this case it's a rectangle. Because this rectangle, we may add many rectangles into the canvas, so we need to use sender. This is not, if I used a rectangle as rectangle, it would not be correct because this is not an object that exists at the moment. We create a rectangle from code, so you need to use sender so you can get the object that is clicked on. Sender is basically the object that triggers previous mouse left button down event. And then because the sender is an object, we need to convert it into a rectangle to access the properties, the rectangle properties. So I got my rectangle from sender, and then I got the mouse cursor position on the main window, and I saved it into a buffer variable. And then I got the object start location. These are different because when you click with the mouse, every time you don't click on the center of the object or the left top corner, you click on the random point of the object. So there's a difference between the cursor and the origin of the clicked object. So I get them both separately. I get the mouse position when I click on the object, and then I get the origin of the object when I click on it, and then I get the object itself. And when I move the mouse, you can see here drawing canvas mouse move. What I do is, after the movement is done, I get the new movement, and from the start point of the click event I saved before, I calculate the delta. Delta is difference. And then I check if my clicked object, which I buffered before in the click event, is a line or rectangle or ellipse. And if it's a rectangle, what I do is I add the delta, the amount of difference between the beginning clicking location and the current location, and I add it to the object start location. You need to get object start location in the mouse click event as well, because if you use get left, it creates an infinity loop and the rectangle moves crazily. So let's try our code. See, very nice, perfect, very smooth. Let's add one circle. Let's add one more circle. See, very nice.
Don't forget to like and subscribe.